Hi everyone. Thank you for tuning into my session at MDC Oslo today. I wish I was there in person to speak, but I'm glad that I can do it online. So I hope that you had a great lunch, everyone. So I will start. So I'm gonna be speaking about developer fundamentals for serverless .NET with Azure Durable Functions. And let me see. Let me start by sharing about myself. I'm Jonah Andersson. I'm a software developer and at Forefront Consulting. It's an IT consulting company here in Sweden. I code fullstack.net. I'm a certified Azure developer, also a Microsoft MVP, a technical trainer, and also the founder and community leader of Azure User Group Sweden. It's a meetup group located in Sweden. And on my free time, I also mentor to inspire others into tech. So when I'm not public speaking, I have a lot of hobbies. I have a Labradoodle puppy. I like to play chess. I heard from one of my friends that are there in the conference that some speakers are playing chess. So I'm missing that fun. I'm also writing a book about Azure, which is actually my first book. And I also like gardening, and I've been working from home for the past year. And I use a desk bike when I'm remote working, and I also like playing chess and reading books. So today, it is developer fundamentals, and what I plan to do is to discuss and share with you what serverless is, Azure functions, what is durable functions, the different application patterns of durable functions that will help solve complex problems in development, a demo, and some recommended learning resources. So I want to share with you about this story. Where I studied computer science and also software development in school. And I had this story, heard this story about the dining philosophers problem, in which there's a scenario of five philosophers, and they had only five chopsticks in the table. And a philosopher, each of them needs to use both chopsticks in order to, from left to right, in order to eat. Otherwise, he or she can't eat. So the purpose of this dining philosophers problem, problem is that there's a risk of having an issue of deadlock, and of course, if there's a deadlock, that means there's a starvation, which means that all of the philosophers won't be able to eat if each of them picks the chopstick from left to right. So, what's my point in this philosopher's theory? So, my point here is that in programming, especially I that works in development daily as my job, one of the worst things or one of the challenges that I've experienced when I was beginning programming was dealing with concurrency or deadlock problems in development. And the definition of deadlock in techterms.com is that when deadlock happens when a program cannot access a resource because it's of course it's blocked, just like what you see in the GIF image there. If all of the cars are like are doesn't have any rules to follow, then it will be chaos, or it will be a problem. So we experience this as well in software development. So for me, I believe that based on my experience, that the problems that we have in software development, like concurrency, racing conditions, or deadlock, can be solved with serverless solutions like Azure Functions or Durable Functions. So before we dig deeper into what Azure Functions or Durable Functions are, we're gonna look into what serverless is. So serverless is actually not really serverless. It just means that there is an abstraction of servers. And the good thing about serverless is that there's an automate. You can automate your processes, your business processes, and break your business process into a logic or small functions. And you can pay as you go, or you can pay only for the instances or the tasks that are running. And because of you don't have to worry about maintaining or updating the servers because the cloud provider is taking care of that for us. We focus more on delivering and we get more developer productivity. And serverless gives us a lot of possibilities in integrating with other Azure services or cloud services or external APIs without limitations, because you can code it in the major languages that we have today. And it is auto scaling, which is hard to do if you have the on-premise or normal like traditional infrastructure. So I'm in Sweden right now, and in Sweden we like to fika. The fika is the word that we use when we spend time taking a cup of brewed coffee with something sweet. So I decided to do a serverless sweet Swedish fika comparison with what the technologies that we have today. So, for example, I compare monolith as a layered cake in which we have everything in one place. We have our databases as servers, web servers, and everything, our monitoring in one place, like on-premise that data center. So that's monolith, like a layered cake. And then microservices are like cupcakes in which you have each cupcake is like a microservice in which you have each service has its purpose. One microservice that takes care of users, one service is taking care of the billing, and you know how it works with microservices. So they're like cupcakes. And then there's also containers. That's a pretty trend today. So they're like cookies in a box. You can carry it anytime you want. Everything is in there. You can go in a picnic. So just like also in containers, it's easy to carry. It's light. It's also fast, easy to deploy, and you have everything in one place. And last but not the least is also the serverless. So they are like small candies. They're very tiny, but it serves its purpose to have something sweet. And just like also serverless functions or the serverless technology that we have today, we can focus on doing or coding the logic that we need in our applications to deliver. And my point with this serverless comparison, it's not actually to make you hungry after you had your lunch, but I know that you have something sweet and some coffee already after lunch. But my point in this serverless sweet Swedish comparison is that the more we go to the left, which is the monolith, of course we have more control because we have everything on premise and everything is in there. But the more we go from left to right, that means that we have better productivity. We deliver faster to our clients. So this is a scenario in which it is dependent to what kind of problems that we are trying to solve. So what is serverless functions? I mean, Azure Functions. So Azure Functions is a compute service. You can create it on demand in different ways. It's pay as you go, and it's the major feature of it is it's event driven. You focus as a developer, you focus on the logic, which means that you have better productivity. You don't have to worry about the infrastructures. And as mentioned, it can integrate well with other services and API. And so basically, Azure Functions is code, the logic that we write as developers in different languages. and it's events and data. So since it's event driven, it gets triggered, or it's dependent on the events. For example, events can be an HTTP trigger, a Cosmos DB trigger, or a service bus trigger, and other triggers that's supported in Azure Functions. And the data is the bindings that we have for input and output, the data in and out in our function app. So that is Azure Functions. And then we also have Azure Durable Functions, which is the main topic of the session today. So Durable Functions is an extension of Azure Functions in which you are allowed, or which is useful if you want to write stateful workflow in the serverless environment. And the main feature, the great thing about durable functions is that it manages, it checkpoints, and it restarts the state for us, which is not normal or possible in a normal Azure Functions. And the technology behind the durable functions is the durable task framework. And you can develop it with C Sharp, JavaScript, Python, F Sharp, and PowerShell. And in this session, I will be doing my demo in C Sharp because that's my language, and that's what I code. And next is this one. So what differs Azure Functions from durable functions? So it's a common question because durable functions is an extension, but Azure Functions is stateless, and durable functions are stateful, which means that if you have a use case or a business problem that requires it to be long running and stateful, then durable functions are worth checking out. So before you can get started developing workflows with durable functions, it is important to know the different types of the technology. So there are four durable functions type. It's first is the client functions. So client functions are triggered by the orchestration trigger binding. And in here, this is the starting point of your workflow. And client functions can be an HTTP trigger or a blob trigger, an event. This is where the event starts, and the orchestrator functions. This is the heart of your workflow, because this is where you write your task, your workflow, how your tasks or activities would be executed and when they are executed. And the next type is activity functions. And activity functions, this is where you write your logic, and this is the unit of tasks that you need to perform in your workflow. And how they are called depends on how you design your workflow in your orchestrator or the pattern that you use, which I will be discussing on the later in the later section of this presentation. And there's also another type, which is called the entity functions, which is ideal in using or reading or updating durable entities. And the difference between the entity functions compared to client functions, orchestrator, and activity functions is that entity functions can only be triggered with entity trigger, and it's supported only from durable functions 2.0 and above, as well as there are only three languages supported for entity functions. Those are .NET, JavaScript, and Python. So of all the types that we see here, I want to focus on the orchestrator, because the orchestrator, that's where we write our workflow. So that means that the orchestrator is our friend. However, the orchestrator is also strict. Why is that? Because the orchestrator is deterministic, which means that whatever we write in the in the orchestrator for our workflow, it needs to be specific and is designed in a deterministic way. And why is that? It's because the entire workflow will be replayed. So the technology behind this can be read about more at deterministic APIs on this link. And there are some code constraints to follow when you're writing your workflow. So this is how it looks with determined orchestrator. So as we can see here, we have a workflow with an orchestrator with several activity functions. So that's how it looks. And this is also to the right. We see isolated Azure functions with a no orchestrator. And the difference between left and right here, for example, on the right, if you have an Azure function or a function app that's hosted or provisioned in a different resource group, and the logical machine in Azure or in the cloud gets restarted, there's a possibility that you loses its state. However, if you have a long running stateful workflow to the left with a workflow where you design how things are done, then it would be easier to control as a developer. And here's the orchestrator code constraints, which means there are do's and don'ts that are good to know before you start coding durable functions. So the first red, it's very red. So the first don't is of course, because the orchestrator is deterministic, it's not allowed to, I mean, it's not recommended to generate random numbers. For example, like IDs in our user management and connection strings, blocking APIs like thread, sleep and runs, and of course, infinite loops and also current date time because current date time is not deterministic. It changes every milliseconds. So what you can do instead is that if you really need to create a random numbers or grid, then there's a method in the orchestration context called new grid. And you can also pass your connection string or configuration in the activity functions. And if you really need to do some control of like threads or async, like asynchronous processes, there's actually great methods already in the durable orchestration context. And if you really need to repeat the process or have a loop, what you can do is make use of the method create as new and call another method or activity function in your orchestrator. And there's also a method called U specific for datetime, current UTC datetime, if you need to have the datetime in your orchestrator. So those are the do's and don'ts, and these are only the some of the things that I listed out. There are more actually in the link that you see below. So now we have the different types of durable functions. We learned more about our friend the orchestrator, and now we also need to know the basic of what are the common patterns, application patterns that we can do with durable functions. So there are 6 documented patterns in the Microsoft Docs. The first pattern is called function chaining. And then the second one is fan out, fan in. And then we also have the third pattern, ASIC HTTP API. And then there's the monitor pattern, and then human interaction pattern. And then there's also the aggregator pattern. So the function chaining is the first pattern. So as the word itself says, it's a chain of sequence or sequence of tasks. So we have a first function here that passed in the data to function 2, the function 2 to function 3, so on and so forth. So if you need to solve a problem that requires a sequence of action that are stateful and long running, then function chaining is ideal pattern to use. So basically, the output of function 1 is a required input of function 2, so on and so forth, depending on how long is your chain. So function chaining in action looks like this behind the scenes. So for example, you have a function app, which is triggered by an HTTP trigger or a blob trigger or a Cosmos DB trigger. So what happens is that your orchestration gets started. So when the orchestration gets started with any type of trigger that you have, the activity 1 is scheduled. And when activity 1 is doing its job, the orchestrator sleeps. Activity 1 is done, the orchestrator wakes up. Activity 2 is scheduled, and then the orchestrator sleeps again. And then activity 1 is done, and then the orchestration is completed. But that's only the first set. So when the event, another event or another trigger happens, the entire process or the entire workflow will be replayed. So the orchestrator just waits for the next event to come. So this is a function chaining pattern example in action. So so the orchestrator is our friend. He or she is strict because he's deterministic. We have to be certain in what we write in our workflow. But it can be also a sleepyhead, just like my dog. So, but it is good for us developers because I mean, even generally for organizations that are using serverless computing, it's because when the orchestrator sleeps in a stateful workflow, you are not being charged for the activities that are not running. So you only pay for what you use, which is one of the uh, great benefits of making use of serverless technologies like Azure Functions or Durable Functions. So how does function chaining works or looks in the code? So as we can see here, this is something probably some of you have seen this in the docs, Microsoft documentation, but here's a very, very simple example of function chaining in C sharp, where we have a function name called hello sequence. And in our orchestrator, through the context, we have a list of strings to output, and then you say hello to the different cities that we have, and return it as output. And then the second pattern is a fan out, fan in pattern, which is useful in different use case scenario. So fan out, fan in pattern is useful, for example, if you want to execute multiple functions in parallel and you want to aggregate the results as one when it's done. And this is useful if you have use case scenarios or tasks that you want to run in parallel. And this is not easy to do. It's not easy to keep the states in a normal functions without using durable. So this is how it looks in code. For example, in C sharp, we are trying to back up site content. And in here, we have a root directory that we're trying to get from string. And we have a list of files that we want to back up. And you do it through the context by calling activity async and called the activity get file list and then return it. And then you go through the loop of the list of files and then copy it to blob storage in a loop. And then you kind of like combine it with the fan in. When you do the fan, this is where the fan in comes when you use the task when all method, and then you return the result of that. So that is a simple example. And then the third pattern is called Async HTTP API pattern, in which it is useful if you want to solve problems of long-running operations for external clients, especially with HTTP endpoints. So this is a simple example that I have. I hope that you can see the code, even if it's black. But here we have, I created a simple function to check if my website is available. And I have my orchestration context with a trigger. And in my try catch block, I created my URL, and then I also created the object for durable HTTP response, which is long running. And I called the method call HTTP async through the durable orchestration context. And I used the method get passed in my URL, and I have below that, I have my HTTP code checked through if else condition to check what's the status code. And then depending on the status code that I have, I throw in an exception, or I can process further or log the content of the result. And so this is an example of async HTTP API pattern that's stateful and long running. And the next pattern is the monitor pattern, which is very useful if you want, as the word itself, it's commonly used for monitoring, especially pulling or monitoring job status or periodic cleanup, for example, and you have a use case or a problem or task that you want to do recurring and long process. So this is an example, like monitoring job status tasks, for example, where we have a timer in your while loop. You set an expiration time, and you're checking what is the status. If the status is completed, you're calling another activity called send alert. And then in your while loop, you have your check. The orchestrator sleeps until the next scheduled tasks are done, and you use a durable timer for that through the context, which is commonly used with context that create timer, your next check, and your cancellation token. And the next pattern, the fifth pattern, is called a human interaction pattern. And this is ideal if you have a use case that requires automation of business processes that requires human interaction. What you can do, one good example is request approval business process. So, for example, you have approval for a paperwork that you need someone's input for approval. So what you can do is you can have a durable timer that you can have in your workflow, and you're waiting for external events. So for example, if a person responds to an email or notifications, you can have a check on that. Otherwise, the durable timer will process the approval after a certain timeout, or otherwise the process will be escalated. So as documented as well, you can see an example in the code here for approval workflow, where in your code you have a durable timeout or durable timer with a timer or a timeout. And then you have a condition when any of those, like the timer or the external event from a person, for example, responding to an email or replying to an SMS, then you can process the approval. Otherwise, you can escalate it to maybe forward it to another person. And the keyword or the method that is used for human interaction is the wait for external event method through the durable orchestration context. And the last pattern is the aggregator pattern, which is used to aggregate data over a period of time as one entity. And it's commonly used for durable or stateful entities. This is how a few examples here for in which you have a counter with different switch case for add, reset, or get, and also if you want to use the durable entity client as well. So you can read more about durable functions entities through the documentation here below. And so those are the six patterns. So we have the human interaction pattern, the function chaining pattern, so the different patterns. So you can use this depending on the scenario that you're trying to solve. And we also have another feature of durable functions, which is sub-orchestration, which means that you can actually create as many patterns as you want, like in different forms, depending on what you're trying or how complex is the scenario that you're trying to solve. So in durable functions, you can have sub-orchestration in your orchestration in your workflow. And it is possible to do only in a few languages so far, .NET, JavaScript, and Python. And this is how it looks in the code. As documented, what we have here is that we have a function name called provision new devices. And then we have our durable orchestration context. We have a list of strings of devices, and what we have here is that we have a loop of the devices and ID, and what we're in each device ID, we're calling the sub orchestrator here to provision the device by calling device provisioning orchestration. And then it combines the method for finding in, which is the when all method. And as for developing Azure functions, there's a limitless of opportunities. We can code it in the Azure portal. You can also use the cloud command line also. But for developing locally, we can use our favorite IDE tools like the Visual Studio, VS Code. And in order to have your function apps or Azure functions running locally, you would need to install the recent version of Azure Functions core tools that are often updated. And for working with HTTP requests, it's good to have Postman. Of course, you can also use your web browser if you want, but I recommend Postman because you see a lot of stuff. And Azure Storage Explorer is also good to have because as we that worked with Azure Functions, we are aware that our Azure the function app needs to be integrated or connected to Azure Storage. So that's where you store the instance logs and the web jobs behind it. So it's good to have Azure Storage Explorer. And supported languages has a lot of options for us: C Sharp, Java, PowerShell, Python, and TypeScript. And if you're into full stack development, that's one of the great things with serverless and Azure Functions, because you can integrate it with almost everything, and it's and you can also integrate it specifically with Azure Static Web Apps. Those that has worked with Azure Static Web Apps, you can create a React, Blazor, Vue in Azure Static Web Apps, but you can also integrate Azure Functions with API support in the Azure Static Web Apps. And then if you already have an existing Azure Functions published in production, you can use the feature, bring your own functions to integrate your static web apps or web apps with existing Azure Functions. And one of the things that I would like to share with you is the orchestration instance details. This is a good if you're trying to if you're developing and you want to control what's going on with your workflow, so this is an example of orchestration details on an HTTP trigger or request workflow that I had. So in my Postman, I worked locally, and this was the screenshot taken then. And one of the properties that are good to know are the instance ID. So this is good to have if you want to redo or stop the process or process the logic further. And there's also a property for or URL for raising the event, terminating, purging, or restarting your orchestration. So this restart is good because probably failure can happen. So there's no perfect application. So as developers, it's not only our job to like develop, but it's also our job to solve problems or bugs. So these are good properties to know within your orchestration details that it's good to control, and you can also use this to monitor or do logging. For example, if you want to make sure that if something breaks in production, you know what orchestration or what instance is causing the problem. So that is something that I want to share with you. And of course, coding durable functions, what are good to know. Application insights, you can use that for monitoring, and Azure Storage Explorer, as I already mentioned. And when it comes to updating or making changes to the function apps that's already in production, it's good to keep in mind to have conscious versioning, deployment with breaking change, and then make use of the deployment slots that we have already available in Azure within the function apps. And I actually watched our keynote this morning, and I find it really interesting about security. I know that there are still challenges when it comes to security, especially with serverless, that you're talking with APIs, external APIs here and there. So as a developer, we have a responsibility to secure our applications, and I highly recommend Azure Key Vault or Azure configurations that we have available when you're developing your serverless functions. And when it comes to error handling, usually with Azure Functions or Durable Functions, you get this common error exception, function failed exception. And what you can do to handle or to prevent these errors is to call another function activity. You can also make use of the automatic retry on failure. Of course, the typical try catch block. And there's also a durable timer, which is very good if you want to take control, just like what the example that I showed on the human interaction pattern, in which you don't, if that person, for example, doesn't reply at all because he or she doesn't have access to his email. So it's good that you have this control in your workflow, like using a timer. And also there's a new feature in durable functions that's recently released this year that's called Durable Functions Monitor, that you can see on GitHub through this link. And this is how it looks when you try to make use of the automatic retry. So you have a timer orchestrator with a retry. So in this very simple example, you are trying to use the method call activity with retry async. And what you do is you create a variable with retry options, creating an instance of retry options, and then you choose the time span of your retry and how many times you want to try to do an attempt for the retry. And then this is a simple example of a try catch blocks. For example, we have a function name called transfer funds within your context or workflow. And then you have, of course, you're doing a bank process here, debit or credit. If something goes wrong with the transaction, what you can do is you can catch it by calling another activity, an activity function is called credit account, to return or transfer the amount that didn't went through back to that person's account. And unit testing is also supported in durable functions. Common frameworks like Mach or XUnit is also supported. So you can unit test both your orchestrator and your activity functions as well. And deployment. So deployment, you can deploy your Azure functions or durable functions as Windows in Windows and Linux in Azure. And you can also deploy it as container and even in Azure Container Registry. And as for CI/CD, you can use GitHub Actions and ARM templates if you want to make use of ARM and infrastructure as a code. And if you already have an existing publish apt in production, you can also publish using your publish pub XML file from that you have saved locally. And recently, after the Ignite, there's a new service that was announced. It's called Azure Container Apps if you're interested to develop serverless containers. So it's fully managed serverless containers built for microservices, and it scales dynamically using Dapper and Kada. And also recently, there's a release of the new version of Azure Functions 4.0 that supports .NET 6.0 and other latest version of languages as well as custom handlers. So I want to share with you, since we talked about security and our keynote this morning was about security, it was a really great one. I learned a lot from it. I also want to share about Cloud Katana that by Roberto Rodriguez, that I personally assisted and volunteered to brainstorm about using durable functions for security in Azure. So what it is that it's coded in PowerShell, and then it uses durable functions to simulate attack and defense attack in the cloud through Azure AD. And this is open source. And as far as I know, Roberto is looking for contributors to contribute in cloud security using serverless and the technologies that we have. So if you're interested, you can check it out as well. So now it's time for demo. I have limited time. Time is over soon. We will see if we have time for questions as well. So my demo is about a serverless function chaining example, a very simple one, just to show how durable functions can be integrated with different services. So what I have is I have an Azure Blob trigger. And what it does when it's triggered, when I upload an image to my Azure storage, for example, when it gets triggered, the orchestration starts. And what it does is that when my orchestrator gets started, I will be passing in my blob image data and send that message to my Azure Service Bus queue. And then when it's done, it's going to send an SMS and call using a Twilio API. And also when it's done, it's going to send a notification email using SendGrid. So in this example, you see that it has an Azure storage here, and then this is an Azure service, and durable functions integrates well with external APIs like Twilio and SendGrids. And my expected, this example, by the way, is on my GitHub repo. If you want to try it out, I created a template for that as well with instructions. And my expected results for my demo would be like this. So I get an SMS, I get a call, I get a message in my service bus, and I will be also getting an email. So let me just see if I can show you some code. Okay. So here I have, let's see. So before I start, I want to show you my screen. I hope that you're seeing the code right now and not my presentation. Yes. So what I have here is that I have a simple app called Durable Storage app. And what I have here is that I am organizing my functions into different parts depending on its type. So I have my trigger, I have my orchestrator, and I have my different activities. And in my trigger, which is the starting point, my client function, I have an iDurable uh, orchestration client in which I have my blob trigger connection. And in here, this in line 38, this is where I kickstart or call my orchestrator to start the workflow. So I save my instance ID as for logging, and I passed in my Azure Blob item. And in my orchestrator, this is where I do my simple function chaining example. So here I have the context, and my first chain is to send the message to the service bus. And then if it's done, I'm going to send an SMS. And then I'm going to send a call and notification, call and then email. And then those are just the few simple ones. And then each activity, I have everything processed here, the logic that I have for sending to service bus, sending a call, for example, and also sending an email through the SendGrid API. And I have everything local, since I'm working locally for now, so I have all my settings in the local file. And the settings can be also used with Azure Key Vault. So I'm gonna try to run this. I actually prepared a number of images from Oslo today for a demo. Let me just try to start my function. I hope it works. Usually this you get challenges with live demos, but I hope this works so I can show you. And let's see. So what I have here, I have my function up running locally. So I know that because I have this one showing. And I also have my local files here. So a few pictures. Let me just try to compress everything in one place. And then I also have an Azure storage Explorer that's already connected to my Azure storage, Azure subscription. And this was the container, the Azure storage container, the blob container that I have set in my code. So get, I will get one image here. It's an image of Oslo. So I will upload it. And what it does, it should trigger my orchestration or function chaining, as you can see here. And I should be also getting an SMS and call right now, but I won't answer. So it happens so quick, those series of events. But what it does is that it is so what's happening is that I started my orchestration triggered by the blob trigger with this image called Oslo, Norway JPEG. And you heard I got also an email. And it started the orchestration with that ID. And then I log everything. So it also sent the message to my service bus, send an SMS via Twilio. So everything is logged. So if I upload one more thing, one more image, it should be shown. So if I check on my Azure portal right now and refresh it and check on my service bus, let's see. I should be able to see one message in my service bus queue uh, using the service bus explorer. So I'm gonna just do a pick on my messages. I had messages before in my queue, so let's see. Picking, and there should be something that's the latest should be today at 13, 2 minutes ago. This one, and and this is the message that I tried to send. So, and this is the picture of Oslo, Norway, in which I wish I was there today, and you are all there. Yeah, so this is my demo, and before I switch back to my presentation, let me just stop this one and finish it up. So those are the expected results that I had. So this is a very, very simple example, just for demo purposes, but you can do a lot of things with durable functions. And if you want to get started learning about durable functions, you can, yeah, there are great documentations on Microsoft website. And I also recommend Azure Functions University by Mark Duker. He is also an Azure MVP that creates like content about durable functions in all levels, beginners or advanced level. And there's a great example of serverless projects in Azure Serverless community that you can contribute and also try to use to try it out. And I want to share also about my Azure user group, Sweden, which is a meetup group. So if you're interested to speak or to just learn about Azure, you can join us in our meetup group. The event is free, so it's about knowledge sharing and about all about community. So feel free to check it out. And I want to end my session with this image that as a developer, I love serverless because I can solve complex problems, just like the example I showed you. I can build modern apps and it makes me productive. Thank you so much. Tack så mycket from in Swedish. So if you have questions, feel free to post it, or you can also ask me or connect with me through Twitter, LinkedIn, or my website. So thank you so much. I hope you learned something. Thank you. Let's see. Do we have any questions or time? Like 8 minutes we have. Let's see. Let me just check. Okay. All right. Can I track? Can I have a questions already. Can I track, visualize the state of durable function task instances, or is just through logs? You can actually track it using application insight. So thank you for the question, Michael. And can all types of triggers be used to start the orchestration? Yes, as long as it's supported by Azure Functions, you can do that, except the entity type. And will the slide be available? Yes, I will share it with the organizers or later if you want a copy of the site's Sindra. And Microsoft recommendation infra puts functions in VNet but need a premium plan, so no more pay as you go. For anonymous question, I think if you use a premium plan, then it's not pay as you go, if I understood your question. Yes. So yeah, thank you so much for watching.